Okay, so now we're going to try to find side lengths in right triangles. So we're supposed to find x, y, and z given this picture right here. Okay, so remember we're dealing with a right triangle, and altitude is going from the right angle to the hypotenuse that forms those 90-degree angles. Okay, we know that 3 similar right triangles are formed, and again we want to know these lengths. Okay. So let's maybe just, I'm going to outline this altitude in red here, okay? And that first corollary said that the length of the altitude is going to be the geometric mean of the product of those 2 segments that are created when the altitude hits the hypotenuse, basically, okay? And so we're going to set it up like this, okay? Is that maybe I'm just going to say this first step, we can say x is to 6 as 6 is to 9. Okay? And what we actually get here, and we can sort of skip this first step if you'd like, but if you'd like to just go right to this and say that 6 squared equals 9x, that would be okay. All right? So we know that this is actually just going to be 36 equals 9x. Okay? And if we divide by 9 on each side, we'll find out that we basically have an x value of 4 here. Okay, and so we could, get rid of this if we'd like, and we could just write the fact that, okay, this is now 4. All right, and I am now going to sort of erase the green or the red parts and maybe write in green now. So again, this is actually going to be 4. Okay, and now we'll look at the other ones. Okay, so, all right, well, we know that this entire length is 13 now, so 9 plus x, or 9 plus 4 is 13, but maybe let's find y now, okay? So we said that the lengths of the leg, is going to be the geometric mean of the length of the hypotenuse times the length of the adjacent segment of the hypotenuse. Okay, so in this particular case, if we were to set this up, all right, we would say that basically x is to y as y is to the entire length of that segment is, again, 9 plus 4, which is 13. Okay, so instead of writing x here, I'm going to write the actual distance of 4. Okay, and so again, we look at this particular case, we end up now with, 4 is to y as y is to 13. And we're going to go ahead now and cross multiply. So we're going to say that now y squared is going to be equal to 13 times 4 is going to give us 52. Okay, and I can now take the square root of both sides. Okay, and that's now going to give me that y equals, I'm going to call this, I know this is the same as rad 4, rad 13, which is the same as 2 radical 13. Okay, so we'll say y equals 2 rad 13, and we're pretty much good to go here. Okay, I'm going to scroll down just a little bit, and let's try to figure out what z is. Okay, so I'm just going to cross this out here. I'm going to write 2 radical 13. Okay, and let's look at this very last part. So I'm going to attempt to erase my green marks here without making too many mistakes. So we know, again, x is 4. We know that y is 2 radical 13. And let's go ahead and look at z. So if we compare this leg, okay, this leg is going to be the geometric mean of the hypotenuse, which we know is 13, multiplied by the adjacent section of the hypotenuse, which is 9. Okay, so if we were to write this out, we would say that shorter part would be the adjacent leg. So I'm going to say basically that 9 is to z as z is to 13. Okay, again, the shortcut for this would just be kind of going to this next step, saying that now z squared is going to be equal to the product of 9 and 13. So 9 times 13 here is going to give us, let's see, what is 9 times 13? I don't have my calculator with me, so I'm just going to check this out here really quick. That's 27. Okay, I'll get now 117. Okay, so z squared is going to be equal to 117. Okay, I'm still going to go ahead and try to simplify this. So I'm going to take the square root of both sides. Okay, I now know that z is going to be equal to radical 117. Now I have to check and see if I can actually simplify this. Okay, so I'm going to run and get my calculator here because I don't want to do this one in my head. Okay, I'm back. So radical 117. Let's see if 117 divided by 4 doesn't work. Okay, let's check 117 divided by 9. Does that work? It's 13, yes. So this is now going to be z equals radical 9 times radical 13. Okay, which is going to be 3 times radical 13. Okay, so that's what z is. So this is going to be 3 radical 13. Now what's cool about this is we can actually check our work. Okay, we can see if we're right by using the Pythagorean theorem. Okay, so let's say, again, a squared plus b squared equals c squared, where a and b are the legs. So again, a squared plus b squared equals c squared. Okay, where again, where a and b are the legs and c is the hypotenuse. So a in this case, we can say this is maybe 3 radical 13 squared plus b, which is going to be the other leg, so that'd be 2 times radical 13 squared equals c squared, which is 13 squared. All right, so this is going to be, so 3 squared is going to give us 9. This is going to now give us 13, so this is going to be 9 times 13. Plus 2 squared is going to be 4, right? So this is going to be 4, 13, rad 13 times rad 13 is just 13, so 4 times 13, and that's going to equal to basically 169, okay? So 9 times 13 is going to give us 117, plus 4 times 13 is 52. We have to check and make sure that's equal to 169, which it is. So 169 equals 169, okay? And we have actually checked our work there, okay? Now again, we'll go through other examples of this, but as you can actually see, it tells us, hey, once you've found the unknown side lengths, we need to use the Pythagorean theorem to actually check our answers, okay? So again, I hope that this example was helpful. Make sure you look at the other one because this is rather complicated, and maybe we'll get rid of that first step on this next one.